Okay, so we want to compute this integral. R is the region in the first quadrant bounded by the ellipse 9x squared plus 4y squared is equal to 1, and 9x squared plus 4y squared is equal to 9. Okay, so like I say here, this is the only type of problem where you'll need to determine the change of variables. So let's start with the equation 9x squared plus 4y squared is equal to 1. When you have an ellipse, the idea is that you want to make it into a circle. So you want to introduce a change of variables that does that. There's a number of ways to do it. X is equal to u over 3, and y is equal to v over 2. Because look at what happens when you plug this into 9x squared plus 4y squared. You get 9 times u squared over 3 squared plus 4 times v squared over 2 squared is equal to 1. But notice this is just u squared plus v squared. So that's what happens to the boundary 9x squared plus 4y squared is equal to 1. And then if you look at the other boundary, 9x squared plus 4y squared is equal to 9. Well, similarly, you have 9 times u squared over 3 squared. This is the same, plus 4 times v squared over 2 squared is equal to 9. But again, that's just equal to u squared plus v squared. Okay, so now you're integrating over a region E in the UV plane. What is the region E? E is the region between the circles, u squared plus v squared is equal to 1, and u squared plus v squared is equal to 9, and it's in the first quadrant, so it's the region between this and in the first quadrant. Okay, that's what the region E is. The function that we're integrating is 6 times sine of 9x squared plus 4y squared, but remember, we already saw that 9x squared plus 4y squared is just u squared plus v squared, and now we have to multiply by the Jacobian, or the absolute value of the Jacobian, du dv. So now let's figure out what the Jacobian is. So remember j of uv, this is just equal to the derivative of u and v. So the first component is the derivative of x with respect to u, that's 1/3. The second component is the derivative of x with respect to v, which is 0. The bottom left component is the derivative of y with respect to u, which is 0. And the bottom right component is the derivative of y with respect to v, which is 1/2. Actually, now that I realize it, I made a typo here. The derivative of x with respect to u is 1/3. Sorry about that. And so this is equal to 1/6. And so this j becomes 1/6. Okay, now if you were to actually compute this integral, this is clearly a polar coordinates integral where u is equal to r cosine theta, v is equal to r sine theta.